Today we'll be solving continuous subarray sum. Given an integer array nums and an integer k, written true if nums has a good subarray or false otherwise. A good subarray is a subarray where its length is at least 2, which means the length of the array should be 2 or it can be greater than 2, and the sum of the elements of the subarray is a multiple of k. Note that a subarray is a contiguous part of the array. Integer x is a multiple of k if there exists an integer n such that x is equal to n into k. 0 is always a multiple of k. We all know that 0 is always the multiple of any number. So the first example, we have this nums as the array. Here we have 23, 2, 4, 6, 7 and k is equal to 6. We need to find the good subarray. So good subarray should contain at least 2 elements in it. Here they have considered 2 comma 4 is a contiguous subarray of size 2 whose element sum is up to 6. Let's visually analyze the solution so that we could code it better. Okay, let's consider this as a given array and this is our k. We'll be solving this question using the HashMap, and here we'll use HashMap to store the remainders. That is the first index where the remainder appears. Okay, initially we will assign the map, the first element of the map, with 0 points to -1. That is because we assume that the remainder of 0 exists before the array starts. This actually helps us when a valid subarray begins at index 0. Now, after that, we traverse through the given array. At index 0, we have the element 23, and the prefix sum is 23. Then, remainder is 5. When you divide this number by 6, you get it as 5. We store 5 at the zeros position. Okay. Then we have at the index 1, we have 2. We add 2 with 23 and get 25. When we divide 25 with 6, we get the remainder as 1. We store 1 at the 1 position of the map, mapping to 1. Okay, these are basically the index. And 2 at index 2 we have 4. When we add 4 to 25, we get 29. And then we have to divide 29 by 6. We get the remainder as 5. But 5 is already present in our map list, right? So yeah, remainder 5 is already present in the index 0. So what we do is current index minus the previous index, which is 2. Current index is 2, and the previous index where our remainder was 5 is 2 or 0. So we bring that 0 over here and subtract both of them. We get 2 as the answer. Now subarray indexes start from 1 to 2. So at the 1st position we have 2, and at the 2nd position we have 4. So those two becomes our answer. The sum is 6. We can check it, like we were given with two conditions, right? One is the length should be at least 2 and the sum of the elements of the subarray is the multiple of k. So sum is 6, and the second condition is sum of the elements and multiple of k. So yeah, 6 divided by 6. How do you find the multiple of 6? When you mod that element with the given element, then if it's 0, then you can say that your number is the multiple of your k, which is 6 over here. Then if it's equal to 0, then you return the answer to be true. Why same reminder works? Because see, check it out here. When you divide 29 by 6, you get 5. And when you divide 23 by 6, you get 5. So it's the same remainder, right? When you minus both of these values, you'll get the answer as 6. And when you divide 6 with the k, and if you get the answer as 0, then your answer should be true. I hope you understood where I got this 23 and 29 from. It's by the prefix sum, 29 and 23. Now let's talk about the algorithm. Firstly, we have to initialize a empty hash map and then store the first element, that is -1 index to 0. And then you have to calculate the prefix sum. Then we will have to uh, find if prefix sum, the remainder of prefix sum. If the prefix sum remainder has appeared before, then check if the length is greater than or equal to 2. Otherwise, store its first index. Else, if it's false, then none of them is found. Now let's code this out in our code editor. First of all, we'll need a hash map with 2 integers. Let's say map is equal to new hash map, and then we will have to put the first element to be 0, -1. Then we'll need one more variable called prefix sum, which is assigned to 0 initially, and then we'll traverse through the given array spelling length I plus plus. We'll calculate the prefix sum. Prefix sum plus is equal to nums of I, and then int remainder is equal to prefix sum divided by, no, it's modulus, right? We need the remainder. So remainder k, we give some space for readability. And if map already contains that remainder, then we simply create one more variable called previous index is equal to map dot get remainder. This gives us the previous remainder. If the current index minus the previous index is greater, like the number of elements is greater than or equal to 2, then return true. Else, if it doesn't contain that remainder, then just add that into our map.put remainder comma I. That's the index. At the end, if we don't find the remainder matching itself, then just return false. That's all. Oh yeah, it's array, right? There's no brackets. Only for string we have those brackets. And then we have one more error, remainder. Variable remainder, oh my god, we made a typo error here. Remainder. Was there any other mistake? I don't think. Map dot contains remainder. Method contains Contains key, it is. Contains key. Yeah, yeah. Now let's look at the time complexity. So we are traversing through the array only once. So our time complexity is big of n. And talking about the space complexity, we store all the remainders of all the array elements, right? So the space complexity becomes big of n. Thank you.